Right now, deep beneath the Atlantic Ocean, an invisible engine is slowing down, and one day it will stop completely. Think about this. London sits further north than New York, much further north, and yet London has palm trees. New York has brutal winters. The reason for that difference comes down to one thing: the world's largest heat conveyor system, AMOC, the Atlantic Meridional Overturning Circulation. Every single second, this massive current system moves roughly 20 million cubic meters of water, pumping tropical warmth toward Europe and the eastern United States. It regulates weather patterns, rainfall, agricultural productivity, and coastlines across the entire planet. Some scientists call it Earth's thermostat. And according to a 2024 study published in Science Advances by Utrecht University, that thermostat is approaching a threshold. Data from the Potsdam Institute for Climate Impact Research shows AMOC has slowed by around 40% compared to mid-20th century levels. A Copenhagen University study with 95% confidence projects a collapse could occur somewhere between 2025 and 2095. Their most likely single estimate? The year 2057. Let that sink in. 32 years. But here's what most people aren't being told. Once a tipping point is crossed, the collapse accelerates on its own. It becomes irreversible, and we still don't know exactly where that point is. In November 2025, the Icelandic government formally declared AMOC collapse a national security threat. Emergency policy development began immediately. Energy, food security, infrastructure, transportation, all under review. Iceland didn't wait, because for them, this isn't a question of if, it's only a question of when. So how does this system actually work, and why is it failing? The answer is hidden in a fragile balance between temperature and salt. Here's how AMOC operates. Warm tropical water flows northward along the surface. As it approaches Greenland and Iceland, it cools. Cool water is denser, heavier, and it sinks deep into the ocean floor. That deep water then flows south, and the cycle begins again, a perfect conveyor belt. But global warming is sabotaging the belt. Greenland's glaciers are melting. Every year, hundreds of billions of tons of fresh water pour into the North Atlantic. Fresh water is light. It doesn't sink. So in the exact zones where deep water is supposed to form, the water is no longer dense enough. The belt slows down. And then the system starts killing itself. A slower current brings less salty water north. Less salt means less sinking. Less sinking means slower current. Once triggered, this feedback loop feeds itself. Scientists call it a self-reinforcing positive feedback mechanism. Potsdam Institute researcher Stefan Rahmstorff described it in 2024 this way. The consequences of an AMOC collapse would be felt for centuries and would affect the entire world. But here's what they're not telling you. Utrecht University's 2024 modeling shows that a critical threshold is already being approached in freshwater transport measurements in the South Atlantic. This physics-based early warning signal is considered far more reliable than statistical models alone. Because this time, there is real data, observational data. And that data is not trending in the right direction. PI researcher Drivhout's 2025 analysis goes further. Under high-emission scenarios, AMOC's deep convection collapses before 2100, and once that happens, full shutdown becomes inevitable. After deep ocean mixing stops, the system closes completely within 50 to 100 years.
We don't know exactly when the system will break, but that it will break, we are increasingly certain. The year 2060, winter. In Amsterdam, temperatures drop to -18 Celsius. But this isn't a cold snap. Meteorologists are being forced to redefine normal, because this cold is the new normal. What actually happens when AMOC collapses? Northwestern Europe and the eastern coast of North America would cool, on average, by 5 to 15 degrees Celsius within a decade. Don't underestimate that number. 15 degrees isn't a climate shift. That's a different world entirely. Think about it. London has roughly 500 years of agricultural infrastructure built around its temperate climate. Vineyards, wheat fields, orchards, all of it engineered for the mild seasons that ocean currents provide. If those currents disappear, all of that goes with them. But the cold is only part of the story. A December 2025 study covered by Live Science found that AMOC collapse could increase drought intensity across Europe by up to 28%. Spain is already experiencing severe drought. Without AMOC, Spain's dry season would extend by 60%. Sweden, 72%. Agricultural collapse, food crises, migration waves. And then there are the tropics. Rainfall belts near the equator would shift southward. The Amazon rainforest is already under pressure from years of drought. As AMOC weakens, the Amazon's most critical systems become even more unstable. In the Sahel, Africa's dryland belt, rainfall patterns are changing. WHOI researchers have directly linked this to growing political instability across the region. 7 military coups in that region in the last 7 years. That is not a coincidence. Along North Atlantic coastlines, sea levels are rising. Without the current, water distribution changes. The eastern U.S. coast is particularly exposed. But the real point isn't any one of these impacts alone. The real point is that none of these changes happen independently. They all trigger at the same time, and each one feeds the others. Scientists call this a climate cascade, and once it starts,
So what about preparation, early warning, prevention? The reality isn't encouraging. There is an international observation system called RAPID. Since 2004, it has been continuously monitoring AMOC at 26 degrees north latitude. The data is invaluable, but it's not enough. RAPID tells us the current state of the system, not the tipping point. Here's the problem. If a collapse begins, scientists would likely need years of data before they could confirm what's happening. By then, the window for meaningful response may already be closed. Because once the threshold is crossed, the system runs on its own dynamics. You can't stop it. You can only watch. Look at international climate policy. Paris Agreement targets are not being met. Global emissions are still rising, and there is a sharp paradox here. Global warming accelerates the fresh water input that weakens AMOC. But some models suggest that after a sudden collapse, temperatures across Europe could drop so sharply that this cooling temporarily masks local warming trends, which means you could reach a point where climate change becomes harder to see, right up until it's too late. But here's what they're not telling you. Not all models agree. A study published in Nature in April 2025 found that wind-driven upwelling in the Southern Ocean may partially stabilize AMOC.
This buffer mechanism could potentially delay or prevent a full collapse. The science hasn't reached a verdict yet, but that uncertainty isn't reassuring. It's more alarming. Because uncertainty means our models don't fully understand the system, and a system we don't fully understand is one we cannot control. The only meaningful action available right now is this: cut emissions quickly and decisively. As PIK researcher Ramstorff put it, this may no longer be enough to eliminate the risk entirely, but it can reduce the risk dramatically. Every year of early action could mean the difference for millions of people 100 years from now.
So, what are the actual odds? Under high-emission scenarios, 70%. Under medium emissions, 37%. Under low emissions, 25%. A 1 in 4 chance of collapse, even in the best-case scenario. When you sit with that number, remember this. This is not just a climate issue. This is a civilization issue. Europe's current agricultural systems, the cities along North America's eastern seaboard, the political balance across Africa's Sahel belt, ecosystems stretching from Greenland to the Amazon, they all have one thing in common. They all depend on AMOC being there. And AMOC is slowing down. PIK researcher Stefan Ramstorff has been studying this system for over 30 years. His 2024 assessment was direct. Even at moderate probability, we are facing a catastrophe whose consequences would last centuries and strike the entire world. We have to take this risk seriously. Moderate probability. Think about that for a second. Imagine boarding a plane and hearing the pilot say before takeoff, "There is a problem, but the probability is only moderate." Would you stay on that plane? Right now, the world is on that plane, and the engine is getting quieter. Science is not certain about the timing, but what's happening is clear. Deep convection zones in the North Atlantic have shown a worrying downward trend over the last 5 to 10 years. Iceland declared a security threat. Dutch and Norwegian researchers are publishing new warning signals. The world needs to start listening. This time, for real. Because the day AMOC's pulse finally stops, restarting it could take centuries. This is the Doomsday Archive. Subscribe for the predictions that matter.